So a few things to know about. Tomorrow, I have a sub. Mr. Nutter will be the sub. There's an assignment that's due at the end of the period tomorrow. Mike, don't step on that. Next minute. And then Monday, Tuesday next week, we don't have this class at all. Or other classes, it sounds like, right?
Yeah.
And that includes the med class, so I get to sleep in. See what it's like. And then Wednesday, Thursday, Friday. So our plan for next week is this. Wednesday we will. So tomorrow's assignment that you will have in class will be review on chapter 4. Wednesday we'll go over that. That'll be the next time we'd have class. Better when you came in late. This was quiet for 25 I tell you. Hold nothing back. So Wednesday we will go over the review and then start chapter 5. Thursday next week we will test on chapter 4. And then Friday next week, we will probably do section 5.2. Then the following week, we also don't have classes on Monday and Tuesday. Something like that, right?
Yep.
And then Wednesday, I can't tell you what, so Wednesday, Thursday, Friday, the following week.
We also don't.
And then we have the whole full next week after that, and then the week after that, spring break, right?
Yep.
Or my off week.
Yeah, you're right.
Oh, dude, that's a lot. 4-day weekend, 4-day weekend, full week, weekend. 9-day weekend.
Yes.
That's the best kind of weekend ever. Other than the one that's, 11 weeks. What's up?
How do you get your graphs to be like that?
I'm going to go over right now. All right. So, let me run through this 4-5 worksheet. Problem number 1 says the number of visitors to Waterworld depends a lot on the outside air temperature. To use how these are related, we randomly selected 20 data points throughout summer. These were the summarized below. Okay, so temperature is going to influence the number of visitors. So temperature is going to be the x component. So let me clear out our stuff for right now. I don't want anything there. I'm going to go into stat, large screen. We're going to edit. I'm going to clear out each of my lists. So I'm going to clear the first list out. This is all stuff you should know how to do. If you don't know how to do it, you need to come see me. We can figure this all out. But I'm going to plug all 20 of those high temperatures in. Looks like you would double check my work. Yeah. Someone call me. Am I listening again?
You're supposed to enter both lines, right?
Yeah. There was a couple questions on that yesterday. So absolutely enter both lines because it's all 20 pieces of data. Alright, so once I have that in there, I need to go back. I believe yesterday I had my stat plot. Look at my stat plot set up for list 1 and list 3. So I want to modify for right now to put list 1 and list 2 in. So I'm going to go down to it, change list 2. And then from there I can go ahead and hit zoom 9. Oops. Wait. Zoom 9. So that's what our data is supposed to look like. So what does LSR stand for? Yeah, that's just our linear equation, right? So let's start putting things on our screen that we know how to do. Thanks to our good friend Winston, we can do this now. Okay, back up. So other things I'm going to do, let's find that linear equation. Excuse me. So stat. Too much talking going on. We're going to do the linear regression model, which is that. Realize we have R and R squared in there as well. So I'm going to put that over here. So that's good to look at. So as far as our initial look at this, we have an R value of 0.876. Good, moderate, weak. It's strong, definitely strong. God bless you. Strong goes from what level to what level? Yeah, so 0.70 to 1.00. So this is definitely falling in the strong range. What is our variance? You're almost right. No, you're right saying the 0.76, but what do I have to do to it to get the variance? Make it a percent. So the variance is 76.8%. So make sure you make your R squared value a percent when it asks for the variance. What does the slope mean in this problem? So 11.6, what is our Y component? Visitors. So 11.6 visitors more attend the park for every 1 degree the temperature goes up. 11.6 visitors. So you got some kid without arms and legs visiting. I'm kidding. Yeah, it's something. So 11.6 visitors are showing up to the park per every increase of 1 degree. All right, so let's do the line of best fit. Or let's graph it. So how am I going to graph it? I've already done zoom stat. Y equals bars. Statistics. EQ. And number 1. And then hit graph after that. Here comes our line of best fit. Squeeze this onto there. That. This over a bit. Winston, I'm so stoked you taught me how to do this, man. You're just awesome, man. All right, so we have our raw data, what the picture looks like. We have our line of best fit. We have our linear regression model where our variance is 76.8%. Our R value is strong. Our data is strong. Okay? So, let's see if we can answer these questions. What does slope mean? We did. What does the y-intercept mean? What was the y-intercept in our problem? Wow. negative 610. So at 0 degrees, we're going to have negative 610 people at our park. So does our y-intercept necessarily make sense? No. What are some things that you might be able to do? Like would you have an outdoor water park open at 0 degrees?
No.
No. I imagine if you look at our graphs, we would be able to take a look and say, okay, there's going to be a certain temperature where we're going to start bringing people to the park, and it's got to be above freezing. Okay, there's no reason to have it open otherwise. So y-intercept is kind of goofy in this case, but it technically does mean if it was 0 degrees outside, then we're going to have a negative amount of visitors to our park. Predict the number of visitors on a day that the high temperature is 100 degrees. All right, so this is using the calculator. What do I have to do in order to get there? Second the trace button. Okay, and I want a value because we're doing a temperature. Temperature is X, right? So we're going to plug 100 in and hit enter. And it looks like we should have 552 people at the park. Notice where this is blinking. Is this extrapolation or interpolation? It's interpolation. Why is it interpolation? Inside of our data. Good. There's a data point to the outside of it. Does that seem like a reasonable amount of people? I think so. Find the value of R. We already have that back here on this screen. Value of R is 0.876. Is it associated positive or negative? It's positive. The warmer it gets, the more people that come to the park. Okay, remember the slope being A and R both have to be positive. They're both the same sign. Find the value of R squared. R squared is 0.768. What is the percent variance? We already talked about that, 76.8%. And now we need to create a residual plot and give the sketch on the thing. So how did we do residual last time? What did we do?
You put in like the data points.
Okay, so what we had to do is we actually had to go through all of our data, the 87, 67, the 90, the 95, the 83, so on and so forth. You have to plug each of those in, and then once they're plugged in, you're going to store them. So I'm going to go second, calculate, and I'm going to run through a bunch of values. So value at 87 is 400. So 400.9 should be fine. And then second, calculate, I'm going to plug in 67. Oops. Will some of you have this already plugged in? Well, you start doing the bottom row when I get there. And will some of you, so who said yeah? So bottom row. Lenny, start from the very back of the bottom row, start at the very front of the bottom row. And I'll just get the second row in. So 67, we're at 68. Okay. So, do you have whole bottom row? So I have the 72 temperature because we had that above, right? Or wait, what was the 72 temperature?
Hold on. So wait, when you do the second trace thing, you put in the temperature, right?
Yes.
Yeah, so then I got 226.5.
226.5.
And then for 88 it's 412.6.
Yes.
424.2.
424.2.
517.3.
517.3.
447.5.
447.5.
238.1.
238.1.
575.4.
575.4.
389.3.
389.3.
528.9.
528.9.
And 354.4.
Perfect. All right, so reduplicating this list. So 87, 67, 90, 95, 83, 84, 81, 90, 88, 101, 72, 88, 89, 97, 91, 86. All right. So with each of these, we had some observed our data that we had collected. Somebody read this for me. 83. What was the given data for visitors for 83? 479. 84. 434. 81. 390. 90. 461. 88. 408. 484 for 101. All right.
Yeah.
So
And then for 72 is
101. 88.
410.
410. 380.
485.
485. 444.
Yeah.
281.
280.
580.
519.
519.
419.
4 for 102 is 419.
Yeah.
No.
And then
Wait. Oh, I have 273s up here. Okay.
86 is 419.
Okay, so that should be 580. That doesn't exist. I should never even put it. 86 is 419, you said?
Yeah.
Okay.
98 is
493, okay.
And then 83 is 418.
418. Okay, last piece of information I need. What was the last data that we did? So I had done the top, so this, I had that, 168.3, 435.9, 5 is 494, 573.54, 366, 332. Point 7? Read me across from 72. Good. Lenny, you got it? From 72, bottom row. No, I'm not subtracting. I'm just writing them down.
Oh, I have to read them for you. Okay. The 72 bottom row.
Yes.
226.5.
Uh-huh.
412.6.
412.6.
424.2.
424.2. 517.3. 447.5. 238.1. 575.4. 389.3. 528.9. 354.4. Okay, I need you guys to do me a favor. So, we are going to now, you're going to take whatever the blue row is and subtract the purple row from it in that order. So, blue minus purple. Okay? So, let's do it this way. Take the first one, take the second one, take the third one, take the fourth one, take the fifth one, take the sixth one, seventh one, eighth one, ninth, 10th, 11th, 12th, 13th. He's sleeping.
See what I do?
So, John, 14th one. All right, well, you'll figure it out real quick. All right, ready? So, what was the first one?
19.1.
19.1. What's the second one? Huh?
Negative 92.3. Wait, what?
That one, negative 92.3.
What do you do? Take the
Blue minus the purple. What's the third one? Negative 25 what? 25.8? Okay. Take the fourth one. 505 minus 494? 11. Who has the fifth one? 125? Okay. Who has the sixth one? 67.9. Next. 58.8. Next. 25.2. Next. Negative 4.7. Next. Negative 79.8. Next. Say that one more time, I'm sorry. Negative 125.5. Thank you. Next. Thank you. Next. Negative 44.2. Next.
Negative 32.3.
Negative 32.3. All right. Next. Someone do the next ones. Negative 3.5. Next one. $42.9. Next one. 13.6. Next one. 29.7. Well, almost there. Two more. That should be negative 35.9. And the very last one, please. 63.6. I missed one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So if the answer is positive, the black answer is positive, that means our line of best fit, that data point, the actual data point, or not our actual, our implied data point is above our line. If it's negative, it's below the line of best fit. Does that make sense? Okay, so what we want to do is think about our graph. So, does it appear some of our data is above the line? Does it appear some's below it? So the positive values that we just did are above it, and the negative are below it. Okay, so what I want to do is now I'm going to take list 1. List 1 was which value up there? X. It's the red. Right? And then I want list 3 to become the new black values that we found. Okay, so I don't have to clear out anything. I'm going to go back to my calculator. I'm actually going to do that. Okay, so what I'm going to do is I'm going to go into stat. I'm going to edit. I'm going to leave list 1 and list 2 there, but I'm going to move over to list 3. Remember when I had said on your calculator, it's important that you go list 1, comma, list 2. This is one of the reasons why that would be taking place. I'm having a third list. Linear, God bless you, linear situations only take place with 2 different columns. So I'm going to go through and I'm going to list each of those. So 19.1, and then if it's negative, I got to make sure I have the negative button, which is the one underneath the key. 92.3, negative 25.8, 11, 125, oops, 67.9, 58.8, 25.2, 4.7. Oop, that was a negative 4.7, excuse me. Negative 79.8. Negative 125.5. Negative 2.6. Negative 4.2. Negative 13.3. Negative 3.5. 42.9. 29.7. Perfect. So now what I want to do is I'm going to do a couple things. I'm going to go into y equals. I'm going to clear out that. I don't need it. I don't want my linear equation in there. My next thing is I'm going to change my stat block. So I'm going to go back into second y equals. I'm now going to turn it from list 1, list 2 to list 1 and list which one? List 3. So highlight over here, hit second list 3, hit enter, and then from here we can hit zoom 9. So now what this is doing is this is the x-axis, so the line y equals 0. So we see our values above and below the x-axis. If all of our stuff sums up to be 0, that means there's just the same amount of it above the line as below the line. The distance above the line is equal to the distance below the line, which means we have a pretty good piece of data. Okay? So there's something, I think I can do this. I got to remember. Let me see. Stat, sort, clear, no. Calculates. I think I the one variable statistics of list 3. Yes, it will give me the mean, median, mode, and range, but I also think it gives us the sum of everything. Nope, because it's... Oh, it does. The sum of all of our values is 10.2. The sum of our values is 10.2. Okay? So I'm not worried about the sum of it squared, the standard deviation, anything like that. I'm looking at, and I'm not worried about the average. I wanted the sum of our list 3, so 10.2. So if I took all my positives and all my negatives and added them all together, I'm coming up with 10.2. What do you think? Do you think it's good for predictions? And this is going to be kind of a judgment call. Is 10.2 visitors going to dictate the success of your park when you're talking about hundreds of people that are coming? Not really. I mean, 10 people at $7 a person is $70. Should that change your operational costs for the day? Probably not. So looking at the number of visitors we're talking about hundreds of visitors. And if I do the summation of my stuff, I think that we have a pretty good residual value to go with. Okay? Now, if my visitors was double-digit numbers, then 10 people could be a lot. We could be off by a lot. But being that we're talking about hundreds of people are showing up to our park most days during the summer, I think our residual value is good. So our residual plot was this. So if you look at the visual representation of what that graph looks like, is we are overestimating a little tiny bit about what our thing does. So let me say that right. So what happens is this here, that's going to tell us that at our line of best fit, if I come back here, our line of best fit, we are getting a larger area up here. So our linear model we found has underestimated what the actual attendance would be. As a business model, is that okay? Like if you figured out what your operating costs were and said it falls right along this line and more people came in that day, what do you call that? Profit. Exactly right. That's what we're doing here. So this line here, actually, because that line here, if I could draw it, that line there is underestimating the number of people coming. That's probably a pretty good thing. We're only 10 above it, so that's pretty good. But because our linear is a little bit more conservative, we actually will show a little bit better profit margins. How could I make the SAT results look better for you all? Have Winston change them. Okay, Winston. I need you to hack into SAT. We need to change the average score to a lower score. And then everyone else here, as far as percentiles go, will score at a higher percentile. Sweet. Winston's on it. We all just got smarter. He'll do the same thing for ACTs for us as well. We'll owe them like $1 each at the end of the school year. It'll be good. So I answered the rest of the questions. We had the residual value. That was the summation of everything. So that's 10.2. Did our regression over or under predict? It under predicted. Find the residual value of a day that the temperature was 72 and 100 visitors. Okay? So what I need to do, my last thing to do, is we have 72 out of 100. The residual value on that day is really bad. 101 minus 226. So that was on our graph, on our data, we wanted to do this guy. That one particular day right there looks pretty bad. Okay? So should we look at an individual 1 point? No. What happened on this day? Weatherman got it wrong. We had a larger amount of visitors show up on the 72-degree day because weatherman probably predicted it was supposed to be in the 80s. Oops. That's just kind of life. And did the regression equation over or under predict? Well, it over predicted what that day should have been. So that's about it. And then let's see, problem number 2. Assume that for any given data, a set that R is equal to negative 0.004, would you expect a large or small residuals? I'd say small. Unless you're talking about a very small unit in decimal amounts. Will the regression equation based on this data make good predictions? Yes. What percent of the variance in the y variable can be explained by the x variable? What percent of the variance in the y variable can be explained by the x variable? Oh, okay, so the variance is r squared as a decimal. If r is negative 0.04, what is r squared? 0.0016. So 0.0016 as a true percent is what? 0.16%. Good. And then if r equals positive 1, then all the residuals will be equal to 0. If r equals negative 1, then all the residuals will be equal to 0 as well. The r being positive 1 means you have a positive slope line. All your data fits on it. If you have r equals negative 1, it's a negative slope line in which all your data fits on it. And then a regression equation being y hat equals 2.5 plus 1.4r, or x. The actual observation, 3 comma 5.5. So you just need to plug 3 into that equation, see what you get out, and subtract that, the 5.5 from that answer. And that's about really all I have to hit on you all. Let's talk about, go to the next page on the notes for 4.6. Is the regression reasonable? Is our regression reasonable? When you create a regression line, is it reasonable? Which we call y hat. Is this going to be reasonable? I think it depends upon which thing of data. If you had data that's all over the place, I don't think it's very reasonable to say, hey, we have a line of best fit that fits this data. Okay? So it really depends. How well does your data fit into that line? That's why we look at the R value. That's why we look at the R squared value and take it out of the variance. Okay? Extrapolation is never to be trusted. Okay? If you truly knew that your model was supposed to be a linear model, I think extrapolation would be okay. But what happens a lot of times in collecting data, well, let's take when a new iPhone comes out. Is there excitement for the new iPhone? You get a whole lot of people saying, dude, I need the iPhone 19.2, okay, or whatever it is. So sales for the first couple weeks of the iPhone are going to do this, okay? And then they're going to do this. So they're going to even out, okay? So if you have data like that situation, don't expect it's going to continue to grow on the initial path. It's going to start to logistically move out, okay? Be aware of extraordinary points. Those are your outliers. If you have something that's way, way out there, way outside your data, be a little bit cautious about what you're doing with it. And then regression can't demonstrate that X causes Y, only some sort of association. So X never, so the explanatory never is affecting the Y. Right? So X is the cause. The Y is the response. So your X variable should control what the Y is doing. And don't choose a model based on R and R squared alone. Okay? So we'll talk about that residual value. So tomorrow, I'm not going to worry about having you guys do in worksheet 4.6. Tomorrow, make sure when you're here, we will be doing 4.7 tomorrow in class. If you forget your workbook, we have copies. But I will go over 4.7 review on Wednesday next week, also starting 5.1 next week. Thursday next week, we will have our Chapter 4 test. Today I have a meeting. Right after this, I have a meeting in my office, but you're still welcome to come over. I just have someone come over and talk to me. And then I have a meeting at noon today in this building. So noon to noon 30. So if you're coming over, and I will not be here 8th period today, I will be off campus. And so if any makeup stuff, probably be best for next week. Obviously Monday, Tuesday are goofy because we have some sort of test that they feel is important.